Hello, scholars. We're in Unit 3. This is our second video. Last time we talked about forces. This time we're going to talk about Newton's laws. Now, Newton made 3 laws governing, or describing, I should say, how objects move. And part of how objects move, or why they move, is because of forces. So last lesson and this lesson are nicely tied together. All right, let's take a look. Newton's first law. This is also called the law of inertia. What is inertia? Inertia is the tendency of an object to resist a change in its motion. So what does that mean? All right, what this says, we just kind of say it 3 different ways, then we'll talk about it, is that an object that isn't moving, an object at rest, is going to stay at rest. It's not going to move unless it's acted upon by some outside force. Some other object exerts a force upon it. Or, part 2 of the law of inertia, if an object is in motion, then it's going to continue in that same motion until acted upon by an outside force. So once I have a certain velocity, I'm going to keep that same velocity. I'm not going to accelerate. I'm not going to decelerate. I'm not going to increase my speed, decrease my speed, change my direction unless I'm acted upon by some outside force. So how do we summarize these two? We do that by saying that the state of a motion, whether moving or at rest, the state of motion does not change as long as the net force on the object is 0. So that net force is that resultant vector. Force is a vector quantity. Remember, we've talked about that a couple times now. All right. So we can combine forces, add them up, subtract them, and if we get the total resultant vector, the net force, if that is 0, then the object's motion will not change. If it's moving, it continues moving. If it's at rest, it continues at rest. So it's essentially like this car saying, all right, I'm parked here. I'm not going anywhere unless you force me to. But once the little buggy gets going, it's going to keep going until something else stops me. Hopefully we can get the video done before my battery runs out. All right, cool. Ready? All right, second law of motion. All right, this is a formula. So Newton was trying to figure out how things are accelerating and decelerating. What are the rules? He took measurements and he derived a formula. Okay, Newton was a pretty smart dude. Curious, looked at his universe, his natural world, and tried to quantify. Took numbers, saw how those numbers were related. So he discovered that the acceleration of an object is equal to the net force acting upon it divided by that object's mass. And that's a pretty long sentence there. We can sum it up with an equation. Acceleration is equal to net force divided by mass. Now we can rearrange the equation. So instead of saying A equals F over M, acceleration equals force over mass, we can solve for M, get M all by itself. And mass is going to be equal to the force divided by the acceleration. Or we can, multiply both sides by M over here. And we get force equals mass times acceleration. This is the way you'll probably see it most often. This is the way it was in your book. But all 3 equations are the exact same. They are equivalent versions, just rearranged. F equals ma is Newton's second law. Now, notice acceleration is in meters per second. Mass is in kilograms. Force is in newtons. What is a newton? A kilogram times a meter divided by a second squared. So essentially it's mass times acceleration. Let's see how this works. So here's an example problem. What is the acceleration of a 5 kilogram object when a 10 Newton force is applied? So we choose our formula. A equals F over M. We substitute in 10 newtons from here, 10 Newton force, 5 kilogram object. Okay, but now I've got an issue here. How do I take care of those units? So I expand newtons because I know a newton is a kilogram meter per second squared. You need to know that. You need to memorize it. Okay, and then what I'm going to do is I'm going to cancel my similar units. Just like I can cancel 2 with a 2 or an x with an x, I can cancel kilogram with a kilogram, and I get 10, where's my mouse there? 10 divided by 5, which is 2 meters per second squared. Those are my units which are remaining. I was looking for an acceleration. That's the units I'm supposed to have for acceleration. So 2 meters per second per second. We'll do more sample problems in class, but don't be afraid of the math. It's not super hard. You just got to be careful of your units. Newton's third law. All right. Newton said, whenever one object exerts a force on a second object, that second object exerts an equal, an opposite force on the first. We can summarize this a little easier. For every action, there is an equal and opposite reaction. You've probably heard that before. I push on you, you push back on me. Why? Because forces come in pairs. The force of A on B is equal to the negative force of B on A. So opposite direction gives me a negative sign. In physics, we write that F of A on B equals negative F of B on A. So the force of A on B is equal an opposite force of B on A. What does that mean? Let's take a look at our pictures. Blow them up for you so they're easier to see on your screen in case it's small. When you fire a gun, we got a sailor here shooting his rifle. The bullet comes out, that's the action, and then the kickback of the gun. In the movie, you see, boom! You have the kickback of the gun after they fire. The bullet comes out, the gun comes back. Action, reaction. You're on a skateboard, okay? You push the skateboard back, the skateboard pushes you forward. Okay? If you have 2 people on a skateboard, okay, we can try this. You push against each other. As I push off the other person, I'm going to move backwards. I'm pushing on them, they're pushing me back, and I move backwards. So, for every action, there's an equal and opposite reaction, and that is Newton's third law. We're going to do a lab on this. We're going to play with this. We're going to explore, but be rigorous as you explore. Take data. Be curious. Try and figure out what it all means, because you're going to see it again on the test. Quick review. You need to know Newton's 3 laws. This is mostly section 2 from chapter 12. A little bit of section 3 with Newton's third law, pages 363 to 373. See it in class to discuss.